metal with some traction engines and railway locomotives and so on. And I've modelled this simply with a plain rod held in two, and I forget the name of them now. Handrail.
Socket.
Support, that's right, yes. As an emergency measure, in case the glass was broken at any time, so you had water pouring out or you had steam pouring out at the pressure within the boiler, you had valves at top and bottom, so you could close off the tube, and they're represented here by brass nuts with brass bolts with brass hexagonal nuts. Now, the other two tubes down here would be metal tubes, and they would go broadly from the top of the boiler, where the steam cavity or steam reception area would be, down to the bottom near the firebox, and these were the blowdown tubes. And they had a valve on them, and the idea was that when the fire grate got clogged up with clinker and rubbish and half-burnt coal and that, by opening these valves, steam at mains pressure up there would be blown down into the firebox, and it would clear out through the flues all the rubbish. So that was the purpose of the blowdown valves there. Now, on the top of the boiler, there is what I would call, well, I must call it one of the two safety valves. And it's a weight operated or a weight controlled valve. If the pressure in the boiler got above a certain level which overrode this weight, then the valve would lift and blow off the excess steam. What distinguishes this safety valve from that one is that this could be operated manually by the operator. It was part of steam regulations from about 1830 onwards that any safety valve on any boiler had to be capable of manual release by the operator. So the operator could, in an emergency, lift the safety valve himself instead of waiting for it to blow up, which was a considerable advance on previous practice. The small thing here is the dash pot, it was called, and it was simply a method of introducing chemicals into the water in the boiler. The purpose of these chemicals, I think, would be to soften the water to reduce the formation of scale and so on. The idea is you put the chemicals in there, drop this lever, and they're introduced into the water. Here we have the main steam gathering point. Steam gathers at the top of the boiler and into here. And by operating this hand wheel, you then admit it through the piping to the engine or close it off as you wanted. And there's a small representation on the side of the steam pressure gauge, which, as anyone who's had anything to do with steam knows, is a fairly useful item of equipment. I've modelled here simply a ladder for going over the boiler, which is essential if you want to get on top of it. This represents the inspection cover which would admit a man into the inside of the boiler when it's cold and switched on for the purposes of repairs, descaling and similar work. And this is simply the second safety valve, which I suppose would be set to operate at a similar pressure to this one. Now, my chimney is transportable. Where outside Papplewick you had about 6 boilers, the chimney was a massive structure, 150, 200 feet tall, situated probably 50 or 100 yards away from the boiler house, and waste gases and steam and so on went to it underground. But each boiler had one factor which I've represented here, not very accurately. Here would be a gate or a barrier, and this could be set by turning the hand wheel on the top, so it was low down or high up within certain limits, so you had a control over the amount of draft that was going through the firebox, and therefore the amount of, shall I say, you had a control over the rate at which steam was being generated in the boiler. So this hand wheel represents that. And since an ideal weight was the triple pulley, which I don't often use, so the ideal counterweight inside the model is another one. But it should be a flat gate. Am I boring anybody? all right?
Not at all. I think this is an angle that very few of us know anything about, and it's something that's always ignored normally. Oh, well, it's a boiler, and we move on to the actual mechanism, and I think it's essential that you know a little bit about this.
Steam at boiler pressure comes down this pipe, and it goes through a valve here, which would be, I imagine, a butterfly type of valve, which is controlled by the governor, which you'll see in a minute, and it then goes equally to the two cylinders here. Incidentally, all the green strips on red plating really represent cladding or insulation. The cylinders that do the work are actually rather slimmer than the proportions of these casings would suggest, because hot steam would go around a jacket that surrounded the working cylinder. The idea with steam is to keep the working parts as hot as possible all the time. So steam would come to the valve chest, which is here, and it would be emitted alternately to the top of the cylinder and then to the bottom of the cylinder to drive the piston that's within up and down. A double-acting steam engine. And it would exhaust out through the pipes I've represented here, and which go to the back of the engine, and ultimately it would go to a device called a condenser, an engine of this nature. The idea being that you're using fairly pure water. It's a shame to chuck it away or let it exhaust to atmosphere. You put it into a condenser which turns it back to fairly pure water, which eventually is recycled into the boiler. The scale of the model was really dictated by the necessity to have a flywheel. As we all know, your choice in the Meccano part is relatively limited. I've chosen to use reproduction channel segments. And they go quite well with the 4-inch plates that I've used for the cylinders. I've got here a little demonstration of how the cylinders are made inside. I don't know if probably you've all seen this. If you take a 24.5-inch strip and curve it into an exact circle, it mounts very nicely on angle brackets on a 4-inch plate. That's the basis of the construction of these cylinders. One of these at the top and one at the bottom, with flexible plates round and then the strips joining it. When I was building that part of the module, I had an obsession with steam tightness, and I went to some lengths to fill in every hole. When later on I came to do the boiler, I realised that this was all rather a futile job. So the boiler is not steam tight to the same extent. It is a closed cylinder, but there's a hole in there where the steam chest mounts up to it. The steam chest is put on as a separate unit later, and it's put on by screwing a nut through that hole into this coupling. Again, something everybody knows, I'm sure. You can use couplings as constructional parts. You've almost got to use them or threaded bosses when you're dealing with a closed space. I tried throughout to reproduce the sort of quality and heavy castings and workmanship that the Victorians are famous for. Hence, there's a rather liberal use of these otherwise fairly useless triple pullers. Each cylinder has two eccentrics, one driving each valve motion. Remember, each of these rods here is in effect an inlet valve and an exhaust valve. So one of these rods controls the inlet of steam to the top and the outlet of steam from the top, and the other one controls the inlet of steam to the bottom and the outlet of steam from the bottom. I've tried to reproduce or represent wherever possible drain taps. Again, anybody who's had anything to do with steam will know that it's very, very important to be able to drain these cylinders in closed spaces, otherwise you get severe damage either to the engine or to yourself. The purpose of the engine, of course, was to lift water from a well underground. And this is something that isn't always clear to a lot of us. The actual well head would be underneath this end of the engine normally, and it might be as far as 150 or 200 feet below ground level. So before ever you started to put this on the spot, you really had to go down to that depth and put in a proper brick wellhead, and also certain iron castings which would constitute the operating mechanism underneath. And you would have a long pump rod from this end of the beam which would drop right down to the wellhead. Now on my model, the idea is that the pump rod is an extension of this connecting rod. It goes right through the cylinder and right down underground to wherever the wellhead is. And that would have on the end of it a lift pump. And the lift pump would simply lift water up a considerable height into a much more local reservoir pretty near to the engine itself. And then on this end of the engine, you would have another pump, which is represented here by this rod, which would drive another pump working in that reservoir, which was called a force pump. And the force pump would push the water out more or less wherever you wanted it, either into mains or into a reservoir or into a canal or wherever you wanted that water to get. And you've got to bear in mind, I think, that these engines were built and designed and they ran for probably 100, 150 years. And most of them, when they were taken out, were in as good an order then as they had been when they started. Now, mechanically, from two other points I thought I'd mention. The uprights here are box section girders, and their construction is not very complicated, but I do sell threaded bosses, and it's important that you chaps should realise what uses they can be put to. You can make a box section girder like this, and it's very useful in this sort of situation. And the second thing is the flywheel, which is made up of, as I say, reproduction channel segments, is held together at its circumference by a similar sort of mechanism. Threaded bosses, fixed on one screw and going into the other one. So threaded bosses are very useful. The motor for the model is a mains motor, a gramophone motor, which I think has made its appearance here before in various other models. And it just turns over all day long, week in and week out. The drive underneath rises on the governor shaft. And from the concealed little box on that shaft, the drive runs along the base of the model to the crankshaft. The way it runs is that it's a continual reduction from the motor to the crankshaft. And this gives a nice scale speed, although oddly enough it seems to be a bit slower at Alcester than it does at Skegness. And it also means that when you look at the model, the governor is turning round a lot faster than the crankshaft, which I think gives the right sort of scale look to it. I don't think there's anything else particular that I would like to say, except that I did take a lot of care to use a lot of brassware on it, because I felt that it's the sort of model that does justice to decoration and decor. Perhaps I could just say, as an afterthought, that on many of these engines there would be supplementary rods and pumps which would operate things like lubrication and which would provide pressure for forcing water into the boiler whenever the operator wanted it, but I haven't reproduced those on this. Thank you.
Thank you.